All right, good day, everyone. This one we're going to call Solving Trig Equations Day 2 because now we're going to dig a little bit deeper into the fact that we're going to start changing it up inside. So everything you guys did last time, it was always on the outside. And we're still going to have those types of things, but we're going to change what they call the argument. In mathematics, the argument, guys, of the function is the specific input of that function. And so the argument for our problems are going to be our independent variable. The things that we normally would change is I can change it for 30 in here. I can put a 20 in here, so I can do 2 times 30. I can do 2 times 40, something along those lines. So that's what we call the argument. Now, we come to this realization, guys, that math is a bunch of rules, a bunch of laws. You can't mess with those things. And if you change them, you're going to mess the whole thing up. It will not work. So we have to stay very consistent. And so what they're saying is that a trig argument in a trig function is inviolable. Inviolable? Because the argument cannot be removed. It means you cannot just say, oh, I don't like that 2 in here by this tan. I'm just going to divide both sides by 2. So this idea right here is wrong. I cannot divide what's inside and something that's outside. So this is no go. You are not allowed to do that. Now, you guys are probably thinking, wait a minute, Mr. Konchak, you have said what I do to one side, I have to do to the other. Correct. But when I say that, I am doing it to the whole entire thing, the whole side. So notice on this one, the 2 is being divided into the whole tangent of 2 theta. Remember, sine, cosine, tangent, cosecant, secant, and cotangent are actually functions. It's the same thing as saying something like x squared. I can't say that you have x minus 2 squared and I can just take and divide by 2 and go like this. Those don't go happen. That does not work that way. You can't do that. And we've talked about that many times because students like to do that. So as I had stated here on the bottom, and I want to read that to you because this is very important, we cannot change this, is that you must consider the argument is a thing or an entity that has to be retained unless you are changing by substitution to an equivalent expression. If you have 4 quarters, you're okay with putting a dollar bill there, and vice versa. But you can't put 3 quarters there and call it fine. And so that's the only time you can ever change something. You can't divide, you can't add, subtract, multiply if it changes it. And so this particular method changes the actual value where this one does not. So keep that in mind. So how are we going to do this? So I've come up with 4 particular steps that we are going to follow. And the first one says that normally when you have these problems, you have something like sine of 2 theta equals 1/2. And that'll be between 0 and theta, 0 equal to theta, which is less than 360. This thing here is the domain. It's saying that theta itself, from over here, this theta, has to fall between 0 and 360. You need to change the argument here and here to make a match. And since I can't change this one, I'm going to change this one. And so to reflect this, this is 2 theta, this is theta. What I am going to do is I'm going to change this to 2 theta. Now, hopefully you guys remember back to Algebra 1 and Algebra 2, and you said, wait a minute, when working with inequalities, what I do to the middle, I have to do to the ends. So if I multiply the middle by 2, I have to multiply the others by 2. Well, 0 times 2 is still 0, and 360 times 2 is 720. So now, here's the really cool thing. I am actually not going to solve this problem originally, as it looks originally, sorry. I'm actually going to solve it for 2 theta. And so, if anything, you can kind of go back here, and I can think of, and I'll box it here, this is some new variable. I don't care. I'm not going to change it though, because I don't want to get people to think that they have to or get used to that. It's just that you're going to solve for the blue box. And so I can actually go back to a little bit more simpler times and say, when does the sign of something equal 1/2? Well, if you think back to here, it's a positive 1/2 here in the first quadrant and a positive 1/2 there in the second quadrant. You take out your unit circles, because that's number 2. It says solve it as normal now. And you're like, hey guys, this is not for theta anymore, this is for 2 theta. And so if you look here, where does it equal 1/2? Remember, sine is your y value, and you're thinking, wait, that's actually fairly easy. That's 30. And then way over here, it's at 150. And so what I'm going to do is I'm going to say 2 theta is equal to 30, and 2 theta is equal to 150. Now, it says you can do that. That's number 2, solve for the equation as normal. So we did that. Now into step 3, it said, wait a minute. It says solve each set for theta. I have 2 theta. I don't want 2 theta, I want theta. So now I can go back and divide everything by 2. So theta equals 15. Theta divided by 2 is equal to 75. Unfortunately, that's not the end of it. Anytime, guys, there is a coefficient in here, it actually will have, usually, if it's a bigger number, like a bigger whole number, like 2, 3, 4, 5, 6, and on, you will have more than 2 answers. You actually will go around the circle 1 less times extra than this number. So this is a 2. So 2 minus 1 is 1. So I'm going to go around the circle 1 more time, which means if I started at 0, I could go all the way around to find the coterminal angle to 30. So what I want you to do is I want you to say, hey, wait a minute, so that means that 2 theta is actually still equal to 30 plus 360. 2 theta is 150 plus 360. And if we do those, I get 390 and 510. And now I can divide them by 2, so it's the exact same steps after that. And 390 divided by 2 is equal to 195. And 510 divided by 2 is 255. So guess what? There are 4 answers. And so the answers are 1575, 195, and 255. And those are the only 4 answers because it wants to know where's sine of 2 theta between 0 and 360. Notice that, whoops, all of these answers are between 0 and 360. If I go around again, so if I took 390 and added 360 to this, so 390 plus 360, I'm at 750, and 750 is bigger than 720. I don't go that far. That'd be for the 2 theta. And then if I divided that by 2, I'd be bigger than 360. So therefore, that's how we are going to vote doing these. So our first example, it's in degrees. And it's again from 0 to 360, as we can see. And it's now solving for tangent. So it's nothing fancy here. 3 theta is definitely inside. 1 is not inside, so that is the thing that we need to get rid of to isolate tangent. Now, as I said before, because there's a 3 in front of tangent, I need to then fix this, which means I need to multiply everything by 3. So 0 is less than 3 theta, less than or equal to 3 theta, is less than 1080. I don't like that 10, so 1080. So another clue, hint again, that I said earlier, that's a 3, which means I'm actually going to go around the circle 2 more times. 2 more times, not 3 times. It's a 3 total times actually. The first pass I really don't count, but then you got to add 360 2 more times. So here we go. Let's talk this through. Tangent of 3 theta, I'm going to add 1 equals 1. Now, how many solutions is tangent positive and equal to 1? So let's think this through. Tangent's positive in the first quadrant and positive in the third quadrant. Using your unit circles, it should be fairly straightforward. This happens at 45 degrees and 225. It's where sine and cosine are exactly the same. So 3 theta, that's supposed to be theta up there, equals 45. And 3 theta is equal to 225. And then from here, you have to then say, wait a minute, I'm just going to divide by 3. Divide by 3. So, I'll put theta. Theta equals 15. And theta equals 75. Now here's the thing. 15 and 75 is actually pretty small compared to 0 and 360. Or even 45 and 225, compare it to 0 and 1080. So I'm going to add 360 to both of the original 45 and 225. So 3 theta is equal to 405, 45 plus 360, and 3 theta, and that is 405, no, it's not 405, it's 225, plus 360 for 585. I'm going to divide both of these by 3, divide by, oops, and then divide by 3. So because I have it on my calculator right now, so that's 195, and 405 divided by 3 is 135. Well, guess what? 135, 195, I'm going to fix that, 195 are still below 360. Heck, 405 and 485 are still below 360. So I'm going to do it again. I go back to those original numbers of 3 thetas. So 405. I'm going to take 405, and I'm going to add 360 to get 765. And then, because I can put this on my calculator, I actually forgot my calculator at school, I'm just going to divide this answer by 3, so 765. I'm using Desmos. It right currently with you guys is 255. And 585 plus 360 is 945. Now 945 and 765, the numbers that we got in this last round, are definitely below 1080. But if I add 360 to 765, this is now going to be bigger than 1080. So you know you're done. And if you don't trust yourself, then do it, find that it's bigger, and then call it a day. And the last one ends up being 315, which is now starting to get closer to that 360 degrees. So how many answers did we have? Well, originally, if that would have been just theta, there would have been 2. 15 and 40, actually, it would have been 45 and 225. But because there's that 3, we actually have to multiply our answers by a factor of 3, and now you get 6. 6. Because you went around the circle 2 more times, or 3 total times. For the last example, we're going to stick in degrees. I think on our worksheet for your homework is also all in degrees. The same stuff applies if it's in radians. But here's the really cool thing. I like these ones maybe a little bit better because it actually goes a little bit faster. Do you notice that this is cosine? So it's a pretty straight up, same thing that we've always been doing with the big 3. But this is theta divided by 2. So that means I actually got to go through and divide everything by 2. If I did 0 divided by 2, it still ends up being 0. Theta over 2 is what I'm looking for, and then theta actually goes between 0 and 180. Guess what? That means you'll have less answers because you don't have as big of a domain to search through. It's kind of like saying that, hey, I can't find my shoes. Well, go look in your room. Well, that eliminates about half the house then where you possibly would wear your shoes. So, here we go. You're going to subtract square root of 3 over 2 from both sides. I think everybody would agree with this. Cosine of theta over 2 equals a negative square root of 3 over 2. Okay, now let's think of this. If I go and say, where is cosine negative? Cosine is negative. Cosine is the x values. It's in the second quadrant and third quadrant. But here's the awesome thing about it, is that I'm looking for where is theta over 2 between 0 and 180. I'm only caring about the first 2 quadrants. So guess what? How many answers are there? Then there's only one. And if you go to your unit circle and say, where is cosine square root of 3 over 2 in the second quadrant? I do believe you come up with a 30-degree reference angle here, or 150 degrees. So theta over 2 equals 150 degrees. I don't want theta over 2. I want theta, so you multiply both sides by 2. So theta is equal to 300 degrees. And that is your only answer, because if I try adding 360 degrees to 150, I will be well above the 180, and therefore can't do it. So, your homework, I do have it written down, is worksheet solving trig equations part 2. It can be found on Power School Learning. And if you have questions, make sure to post them on our Google Hangout. Or drop an email. Make sure you guys are talking to each other, helping each other out at all times. Lend a helping hand. If you're absolutely getting this, lend your services out on Google Hangout. And hopefully everybody's getting outside while it's getting a little bit nicer out and enjoying your day. See you next time.